Hello? Awesome. Cool, let's get started. So, good afternoon. Welcome to my talk. I will be talking today about gaming-specific blockchain infra in the next chapter of blockchain games using fully on-chain paradigm. And first, briefly introducing myself. I'm Yijia. I'm co-founder of Curio Research. We are a crypto-native game and infrastructure company dedicated to supercharging the success of on-chain games or blockchain games in general. And today, I'll be talking about a couple of things. First, all games should start from the experience it creates, because unlike DeFi, games succeed because of the holistic experience that they engender in players, right? That's the number one thing people care about. And I will argue that with on-chain games, and especially fully on-chain games, I'll explain that term in a bit, there's a massive design space that just opened up for game developers to really express and for players to experience. And these design paradigms need to be based on some tech infrastructure that is really beyond what today's blockchain infra can support. And that's why my title is about this blockchain infra. So before I dive into the details, allow me a quick philosophical detour. What makes the real world feel real to all of you? Is it just the rendering quality? Obviously higher than all the games you played, but is that all of it? Humans have been social animals from the beginning, whether we live in small villages or sprawling cities and large states, very powerful states. The social relationships, the relationships we have with other people are very complex, whether it's with your parents, with your family, with your colleagues, and they are great assets that are held by us and perhaps the greatest gift of humanity. However, if you think about the online games, the multiplayer games you played, is there a game that have matched the complexity and the interestingness of real-life social interactions? I'm guessing the answer is probably not. But why is that? Let's take a moment to look at the current social layer in multiplayer games. Does anyone recognize this game right here? StarCraft. How many of you have played it by a show of hands? Or maybe see your friends play it? Cool. So StarCraft is a very classic RTS game that allows players to compete, right? And we get it. The thrill of commanding a group of armies and annihilating other people's armies is quite hard to find in other places. But if you think about the social interactions in StarCraft, it's very simple. Players compete with each other. There's minimal cooperation or collaboration that happens. And this is very common in the type of game that we call social 1.0 games, where PvP is the main interaction, and there's minimal cooperation or any other interactions in between. There are lots of games from 30, 40 years ago when video games first became a thing to today that follow this social 1.0 paradigm, such as CSGO, Overwatch kind of, PlayerUnknown's Battleground, a lot of these games, right? They're interesting, but not in terms of the social aspect. Then we have what we call social 2.0 games, which most MMOs are. Social 2.0 games, on top of the PvP or peer versus peer relations, right, the competition, it adds a layer of group or collaboration with its game-defined alliances and guilds or groups. So the primary interaction that happens in this type of games, basically all the MMOs like World of Warcraft, EVE Online, are collaboration within a group and competition between groups. And there's not much else. And this is a huge step forward, right, from social 1.0, because all of a sudden, you're not just trying to kill all of the other players that you see in the game. There's some kind of relationship, perhaps most often find a hierarchy within a group So this picture shown here is Rise of Kingdoms. It's basically a more longer form and many more players type of civilization, but less strategic. It's a MMO tweak of the game, of 4X strategy games. In this game, a game often runs for a season, sometime from 2 months to 3 months, and players are organized into guilds, which are absolute groups that usually players don't enter and exit very frequently. And within these groups, there's a very strong hierarchy. There's usually one or at least, at most, a couple of guild leaders who are usually the biggest whales, who put in the most money and often time. And these players have tremendous power over the smaller players who simply play the game but do not spend that much. And the game developers often only really care about the players at the top. And as an ordinary player, let's look more deeply at the social relations in these type of games. Where, let's say you are a player in the guild or group on the left, and let's say you want to do anything or interact in any way with the player that's highlighted on the bottom right. Let's say it's if your guild wins, you are willing to share some of the gains with that player. Or let's say you want to trade a rare type of resource for your own benefit, which is very common in real life, right? You can't do that because the only type of meaningful relation between you guys is the competition between your guilds. There's nothing else, right? And similar, this does not limit to the individuals. It also applies to the groups. If the guild leader of the guild on the left wishes to sign a peace treaty, right, with the guild on the right, and let's say concentrate and attack the third guild, they also can't do that, or maybe they may verbally agree, but there's no real consequence if one side reneges on its promise. This is fundamentally why online games have been struggling to recreate or mirror the diversity of real-world social interactions. Now let's take a step back and envision a specific scenario. Let's think first a bit about what the real world does better than these online games at social interactions. Fundamentally, we think the real world has two very important components that constructs the social layer for it to be complex and interesting. The first is truly valuable assets, such as definitely not just your CSGO skin or these game items that worth at most maybe a couple hundred or thousands of euros, dollars, whatever. There are things like your house or the very expensive jewelries you have, whatever things that you really, really value that make you care about the experience. And on top of that, there's an effective law enforcement mechanism that protect people's interactions around these assets. And this way, right, you don't have to, let's imagine you go to work with your colleagues. If you enter an argument with your colleagues, you don't have to worry about them seizing your house or killing you, right, because there's the law enforcement. And we make a lot of deals every day. These are the fundamentals of interactions we have with other people. But we usually don't have to worry too much when other people breaks the promise because it don't happen often. And if it happens, usually they'll get punished. But this is not the case for online games, for digital worlds. What would be a solution to this? How would on-chain games or online games catch up? I keep spoiling it. In fact, blockchain games have already provided half of the puzzle, which is a real way to have valuable assets online and share with other players in a way that other players can see. We already have a lot of innovation, without me needing to mention, innovation in digital assets that are decentralized and very, very secure, comparable with real life. Some would even think more secure than real life. But what's the other half of the puzzle? The part that actually enforces people's promises, that allows people to interact with others without worrying the validity of each. Let's imagine a specific situation in a hypothetical grand strategy game. In this strategy game, like typical strategy games, you start with maybe a capital, some troops, and you have a clear objective, such as conquering the great city in the middle. And in the process, you encounter this player named Vitalik, who's not that strong along the same level as you. And there's a couple, let's say there's a couple of gold mines that's sitting between your territories that are just changing hands because you both want them very, very bad. One day, Vitalik texts you and says, F, I see this guy named Justin Sun approaching us with lots of level 5 horsemen. Gonna lose if we both continue fighting each other. And you say, okay, what do you want to do? Vitalik proposes that you stop attacking each other for 3 turns only, right, as a beginning of a gesture of friendship. And whoever violates this must pay the other 500 gold. This is pretty natural, right, in real life. And you agree to it. You think it's a good deal. Now, in 2 turns, you thought about the situation again, and you're like, no, I want the gold mines. I'm going to attack Vitalik anyways. What do you think should happen in this case? Well, justice seems to say that Vitalik should get your 500 gold, right, because you broke the promise. But there's no real way to enforce that in current multiplayer games. And so, but the ideal stage is that you have the game engine who's basically, all-powerful, which can change any state, to understand this promise that's made between you and Vitalik, right? And to execute that, to automatically, let's say, deduct 500 gold from your own balance and give it to Vitalik. How do you do that? So there's 2 parts to that solution. One is the game engine understanding this interaction or this deal between 2 players. And that kind of alludes to large language models, right? In this ideal user flow, where you basically have a chat like real world, and it interprets that into something, right? And the second piece, so this first piece is very interesting, and we do see AI and LLMs becoming much more powerful in the past year and a half, but it's not quite there yet, even though we know we'll get there, perhaps within a couple of years. But the second piece is very tenable, which is what language, or what's the computer language that really this human language is translated into, right? That's able to execute whatever interactions or whatever deal players make, or whatever contracts player makes. We thought about this a lot internally, and we came up with a solution called treaties, which is basically using smart contracts for social contracts. It's very simple. If you think about it, smart contracts have been the contracts around financial assets, right, in the blockchain world. And essentially, treaty is basically using that for more context-rich gaming worlds, where there perhaps isn't just a couple of rules, but a lot of rules, right? We have same as we have a lot of physical laws in the current universe, and anything that's within the boundaries of that physical laws. So a player cannot propose that they generate 5 times more gold every turn, but they can propose that they lend the gold to someone else for some benefit, right, with some consequence if that promise is broken. That is very powerful. And without going too much into technical details, essentially think of treaties as the new social building block of digital worlds. In similar way as a physical building block might be seen as the Minecraft block, and etc. This will be essentially the missing piece to having multifaceted social interactions like in real world, in online worlds. And what can this be, right? Let me give some examples. Simple things can include non-aggression pacts, such as what we saw in the Vitalik example. But you can also have very complex examples. For example, NATO, North Atlantic Treaty Organization, which is essentially a defense pact. You can have guild currencies. Imagine Saudi Arabia launches a currency that's one-to-one backed with oil, which is a very high-value in-game resource, right? And you can even have on-chain democracies or other different government forms, which allows the community to govern and to elect leaders and to set policies, etc. All of these are possible with smart contracts. And treaties, therefore, are uniquely suited for blockchains, right? A lot of people have asked me, why is this not doable in Web 2? Well, there's a couple reasons why. One, it's actually possible if the game company anticipates every single way players wish to interact with each other, right? But think of how impossible that is to, even in a very simple game, to anticipate what exactly players want to do with each other. And that's why only when the game logic is on-chain, aka fully on-chain, right? And fully verifiable as a result, does this treaty system actually work, right? Does that part make sense? Yeah, so this is like a huge breakthrough in our opinion. And we made a game out of it. So previously, Curio, we started building on-chain games right after Dark Forest v6 in end of 2021. Where we saw a lot of community participation, and we thought, oh, this is a very interesting field, and there's definitely a lot of innovation, though we didn't know what quite that would be yet. But when we thought of treaties, we were like, holy shit, this is huge. And we built a game that is a fully on-chain game otherwise, but incorporates the idea of treaties in the game. So in this game that we launched in January 2022, 2023, this year, we had, I think, around a dozen or so treaties with, if you count the parameters, a couple dozen. For example, non-aggression pact, you have embargo pacts that allow people to place embargoes on each other. You have lending contracts, and fun story actually, right? So this game was a battle royale game where the objective is to conquer the middle tile and hold it for some time. And there were two kind of loose alliances towards the end of the game. One was a couple of players that formed a very strong alliance, and that they basically held the middle tile to around 12 hours before the game ended. And they were basically about to win, right? However, I think around 5 or 6 hours before the game actually ended, the final victor signed a troop lending treaty with another player who happened to have a lot of troops and was next to him, and borrowed a lot of horsemen and just went for the center and actually won, right? So treaties actually affected how the game turned out, which like when we built the game, we completely didn't anticipate. We thought people would just treat it as a toy. And this confirmed our belief into this social 3.0 world, where social relations in the social layer will increasingly mirror and draw from the real life. People really enjoyed the game, proof. And yeah, and we are, at Curio, we're building a breakthrough real-time war strategy game after that with high stakes. I would say, all of our games built before are more like demos that we use, or POCs, proof of concepts, that we use to validate certain concepts. This one is real. It will have the complete experience, the complete economy elements and all of that, and fully on-chain. And I haven't still talked about the infra element. So let's get into that. Let's take a step back and look at this point, I've talked a lot about the social layer, the social component, fully on-chain, right? And hopefully you guys have a broad sense of why blockchain games and on-chain games have a unique take at solving the social problem in digital games. But what exactly does such a game need? I've talked about a couple slides ago, right, that there are two very powerful and central components, which are the social composability. So you need to have a system for the player to draft up arbitrary interactions. The final form is language models or chat, but the intermediate stage would be something like smart contracts, which the system can interpret and execute on its own. And you also need the trustlessness of on-chain assets that provides a defense of players' assets. But at the same time, right, you also need things like high performance, great graphics, slick UX, all of these things that great games often need, right? Without those, it's just much harder to have a scenario where you need and would have a lot of 3Ds in the first place. To be more specific, right, let's, the screenshot on the top and the bottom left is from our 3D game as well. If you look at the last 2 lines, this player called Xerox Hemdall was saying the blue ones don't move, but you're trying really hard to move, and the red ones don't attack, but you really want to attack. So the context for this was that we built 3Ds on a basically EVM, like a fully smart contract-based game logic type of architecture, where all of the game logic lived as smart contracts in addition to the 3Ds or the social contracts. But the consequence of that was the blue ones actually did, like basically the troop when moving would blink blue, and when it's attacking would blink red. But the time from the moment of intent to the actual execution by the system was so long. It was something around 15 seconds where people were like, are my troops truly moving, or am I doing something wrong? That is not an ideal experience for on-chain games, right? And a lot of the current on-chain games, including Dark Forest, which is probably the most well-known on the top right, kind of avoid this problem by limiting its design space to actions that take a long time. So even though Dark Forest and a lot of games say they're RTS or real-time strategy, every action in Dark Forest usually take somewhere between 15 minutes to several hours, just because of the performance constraints of the systems, right? And that's drastically different from the games that we think of when we think of multiplayer games. So how do you solve that? A lot of people actually think, on-chain games are interesting. You might have all of these interesting social components, but it's just never going to be fast. It's never going to be, pretty. That doesn't have to be the case. Again, first principles is helpful here. And before I dive into our solution, right, the specific problems is that, first of all, when you have a complex game, the TPS is very slow, the transactions per second. And the reason here is not quite with the execution layer. Like EVM itself doesn't have a problem when it comes to DeFi or a lot of other purposes. But for games, because games have a lot of context, right, the transactions are often hundreds or thousands of times bigger than DeFi transactions. In our game, for example, each transaction averages in tens of millions of gas to hundreds of millions of gas, which is something that cannot even go on mainnet, let alone count for a typical DeFi transaction. And this is not even, look at our game, right? This is not something that you would play with like millions of players. This is a fairly simple game. And yet we already hit the bottleneck, even with a single node EVM rollup. And what makes it worse is that today's blockchains don't even have a native game tick. And again, this is not something that the Ethereum team thought of, right? It was not built for games. So what does game tick mean? Let's say you want to move from point A to point B in any MMO game, right? The intent of moving from A to B is an intent, and then the action, what actually happens is the game moves your little unit every unit distance, let's say like a small tile to the right or down or whatever direction. And that happens many times before you actually get to point B. But in today's blockchains, there's no such thing as letting the system do that for you. The player has to send the transaction for every small movement that actually takes place and changes state. Basically, any state changes need to originate from a transaction. And why is that bad? Because one, it's very unintuitive, and two, there's a lot of repeated computation. For example, every time you move, you probably need to check, oh, is the army yours, right? That part is repeated, which adds to the performance bottleneck. And finally, for those of you who've written Solidity, I hope you already understand, it's just not the easiest language to work with, especially when it comes to complex systems like games, even with Foundry Test Kit. With all of these problems in mind, we've spent a couple months in the past till today, building Keystone. And Keystone is a revolutionary roll-up-based on-chain game engine framework made specifically to 100x performance of on-chain games. And by the way, the 100 is an understatement, not an exaggeration. So before diving into details, let me show you a demo, which we already posted on Twitter today, but I'll just show it again. So essentially, we used the Warcraft assets of Warcraft 3, which is one of the earliest, not earliest, but most popular RTS games. And we put everything on chain. Everything you see here, the logic, the movements, the battle, the locations of trees, the buildings, and the armies, everything happens on chain. And I don't know how familiar you guys are with the current state of on-chain games, but if you look at some other on-chain games today, this is like a huge, more than 100x performance boost. Yes? Say that again. So this is, Keystone is sovereign rollup based. Basically, yeah, I'll get to the technical next slide and after. Yeah, great question. Yes, all actions, yes. Not the rendering, but all logical actions. Cool. So, yeah, the features of Keystone, it's first of all a high throughput ECS-based game engine. ECS just stands for a way game stores the data. And it has fast game tick, supporting any classic RTS style games. A lot of people ask, why not StarCraft? It's because we can't use StarCraft assets, but totally you can put StarCraft or a similar game on chain. It supports historical state querying, so this is very important for treaties. Let's say you sign with a player, if you don't attack me for 3 turns, I'll do something for you. The 4 3 turns part is not about the current state, right? It's about a historical phenomenon, and you need to be able to query for that. And obviously, Keystone supports easily integratable smart contracts, social contract execution, and it's completely EVM compatible. All of the smart contracts are written in EVM, in Solidity. And the game logic is written in Go. So specifically, the architecture is as follows. And feel free to come ask me more questions afterwards if you have specific questions. Briefly, we have 2 things running side by side with each other. One is the Go-based game engine. Okay, the text is kind of small. I'll try to zoom in a bit. On the right, you have the game engine that is written in Go, and basically it has all of the game-specific optimizations like game tick and embedded indexer, so you don't have to have an external indexer, and a lot of other nice things that blockchains don't have. And on the left, you have the EVM, modified EVM, where it executes the user's smart contract that represent the social interactions. And the 2 systems interoperate with stateful precompiles, which are essentially the EVM's custom functions, think of it that way. And the game state and data when the game is running gets settled or posted to Celestia for data availability, and then also to an L1 like Ethereum or any other L1 that the community chooses in the spirit of sovereign rollups. And on the L1, there are a couple contracts such as Game Manager and Game Staking that manages the financial or the heavy financial elements of the game. And the sequencer, right? So let's say there's a couple of multi-sig sequencers or community guardians that can run the game, and the multi-sig has the power. Actually, the entire community has the power to monitor and examine whether the guardian who's running the game has cheated or acted maliciously. And at any moment when that happens, the multi-sig can vote out whichever guardian is acting maliciously, replace that, and invalidate all of the the mistaken financial results from that period of time. So from that perspective, it is optimistic. It's kind of like Arbitrum setup, actually. So yeah, with setups like Keystone, which really take a step forward from the very vanilla EVM approach, right, and adds a lot of the game specific stuff. We believe this is the first steps toward social 3.0 games, where you don't just have PvP or GVG, group versus group, but you have an array of different types of interactions where the line between friends and enemies are blurred, just like maybe you and your colleagues or your parents. You know, and it's with these infrastructures that we think games or worlds like Ready Player One can truly emerge from. And finally, what is Curio doing to advance this plot, right? There's a couple things. First, we've already actually open sourced Keystone on our GitHub repo, so feel free to check it out. But you know, at this stage, by the way, it's a very, I would say, early and primitive model. We welcome all suggestions and feedback, and we want you to actually stress test the system and tell us what is inappropriate, what can be better. And we're taking several weeks to launch V2, which will be, you know, better tested. It will have much more documentation, more friendly to third-party, to community developers. We are, as I said earlier, building our flagship game, taking into account a lot of these design paradigms that just opened up, and hopefully build a really fire game that people remember this is uniquely fully on-chain. And finally, probably the most important, we realized that the extent of new game design space that's opened up is way beyond a lot of people's imagination. And we alone definitely, we both don't want to and don't have the capacity to explore all the design directions that may be valid, right? And that's why we've decided to take a very active and proactive approach to support people who want to build on top of Keystone, who want to build on-chain games. And we will provide helps that are way beyond the typical hackathon level of help. We will provide you with, connect you with our team that you will need. We might even provide capital. We will help you think about how to you know, have your game on-chain, etc. And if you're interested, just come reach out to me. Details will come out probably next week or so. Thank you, and see you on-chain soon. Yeah, open for questions.
Hi, thank you very much. Quick question, was Treaty built up on top of mud at first, or did you use any custom ECS? And second one, so we saw Dojo this morning. Did you benchmark it, and how fast would be Keystone against Dojo, for instance?
First question, we've always built on our custom infra. I would say our first version was quite similar to MUD. Basically, it's like a fully smart contract ECS-based engine, if you call it. But it's like a game backend server that exists on the blockchain, right? So it's pretty similar. But we wanted to have a lot of custom stuff, so we basically built it on. And you were asking about Dojo. From my understanding, I didn't read the Cairo code, but Dojo is very similar, I think, to MUD today. And Keystone is therefore a fundamentally different approach of having the game in-chain rather than on-chain in that sense, where, yeah, you basically have, you know, the EVM that processes the social contracts, and at the same time, the game that runs in parallel with the EVM and interoperate with precompiles, right? And I don't think the current systems actually have anything like Treaty in terms of the game design. So there's two kind of big differences. Yes.
So I work at Aragon, and I'm super intrigued by the connection that could exist between groups and teams within games and like it's like an on-chain organization. I'm wondering, you mentioned some games that are like armies, you know, wider teams. Is this
So you're asking about the relation between the groups, the team plays, and the kind of on-chain communities? Yeah, I mean,
So not even on-chain communities, like the team players or people playing together
Right.
being this on-chain community.
oh, I mean, that's definitely something that can natively occur. I think right now we just haven't seen good games that people even want to do something like that on. But yeah, totally. I mean, on-chain communities or like communities are a form of social organization. You know, like a DAO, for example, can have its own social contracts that govern how leaders are elected, how policies are passed, right? And you can totally have that in the game context, extend that the game context as well, in many ways. Yeah, that's definitely a very interesting direction.
Hey, this is John from Open Fort. I'm wondering as well, when it comes to rollups as a service and like everyone kind of like spinning out their own app chain, do you guys will make it available for games to decide whether they want to have concepts like account abstraction natively, or like what are your views on like smart contract wallets having to be deployed on each different rollup based on the game, etc.?
So there's kind of two questions there. One is like what we think about account abstraction and deploying on different rollups, and two, like about just rollups as a service in general. Is that?
Yeah, like first one would be, do you have the customization to make it natively on the rollup, like account abstraction natively?
I mean, yes, definitely. Like we plan to. It's just not the absolute top priority right now, but it's definitely like, for example, a big pain point in traditional games is when you have to, you know, sell accounts or borrow accounts for a couple days and then return it, right? That's definitely something that blockchains can solve very well as well. So definitely, yeah. And then in terms of how we think about, sorry, what was your second part again?
Like how are you thinking of you know, EOAs versus smart contract wallets when like thousands of players come to a specific rollup and they
Yeah.
want to start interacting?
Well, I think they serve as different roles, right? Like the smart contract wallets, for example, in a treaty can be a smart contract wallet, which like let's say you have like a like an in-game treasury or of some sort that a couple of wallets addresses control, then you know that wallet can have its own assets that are controlled by maybe EOA wallets. In some, like we had that in our previous game actually. I forgot which exact treaty it was, but it had its own armies that I think it's a collective defense fund. But yeah, I think there are many different ways you can integrate and compose these things. Yeah, that was a good question.
Well, thank you for your talk. It was very interesting. I just want to know maybe more about the ticking system and how do you enforce automatic smart contract execution? What's the technical behind all of this?
That is a great question. So I would, to repeat the question, you're asking about the tick system when it comes to automatic smart contract execution, right?
Yeah, well, because I know that there's someone who's building a similar system in the OP stack, and he was enforcing ticking in each block, and I don't know how do you handle that, and just want to have some feedbacks on that.
Yeah, that's a great question. And basically you notice that the tick in smart contract execution might be different from the tick in the game, right? And that is actually a correct observation. So in the case when treaties can be verified, aka run or executed within the tick length of the game, let's say it's like every 100 milliseconds, then they can just be the same tick. And basically, let's say we have a treaty that says you cannot be on my territory, and if you step on my territory, like you have to pay me 500 gold, right? And that basically is checked every time you move onto a new location, right? The treaty runs and sees, okay, like, you know, sorry, what's your name? Yeah, you get the idea. But if it takes longer, right, then there's a couple solutions. One, you could have kind of, and these are all, brainstorm as they might not be the final solution. One way you can do it is you can have a longer tick for the smart contract side. Every, let's say it takes like 500 milliseconds to execute the smart contracts. Then you have every 500 milliseconds run that and then like revert all of the changes that actually shouldn't have happened in the game side. And that's kind of like a judgment day type of logic. You could also just manually extend all the game ticks to match the smart contract. And you can also limit the complexity. There's many things you can do, but yeah. Does that answer your question? Yeah. And then in terms of ordering, right? I think absolute ordering is more important in DeFi than in games. In games, you can totally have some scenarios where, it just happens to be that the other person's treaty executes before you. And maybe that has some minimal consequences. We'll make the design so that it doesn't hurt too much. But we think that's not as big of a negative consequence in games compared to DeFi.
Thank you, sir.